So we proceed. Question 4 of the same sheet 7. Find the equation of the tangent to each of the following curves at a given point. The equation of the tangent, one word is missing there, the equation of the tangent line. So that to do so, for A, the equation we are dealing with is 2y squared minus x squared is equal to 1 at a point -1, -1. To find the equation of the tangent line, you know the equation itself is supposed to be y is equal to mx plus c. What you don't know here is m and c. How do we obtain m? To obtain m, to find the gradient, m, differentiate or in other words, find dy dx. So we'll differentiate here using implicit. So say 4y dy dx minus 2x is equal to 0. So that dy dx is equal to 2x over 4y, and then substitute in this guy, substitute the point given, -1, -1. So it will be 2 by -1 over 4 by -1, giving us 1 over 2. So this is our m. So we go back to y is equal to m, now with our m known, plus c. Another question is, how do we get c then? To get c,
where has 1 gone?
It has been differentiated.
Okay.
So Mwepo, you stop scribbling on the board. So you got -1, -1. Where there is y, you take -1.
Excuse me, sir.
Okay.
Yeah, a bit too fast. No?
Oh. Let me slow down. So the reason why I became a bit fast is because differentiation is now in our blood. So when we say you differentiate quickly, and then it becomes slow when doing other new things.
Yeah, and one of about 12 minutes.
11 actually. Okay, it will be slow so that you don't just waste this time. So the key thing is that whenever you're asked to find a line, the equation that you use is this one here. Okay, now there are two things missing there. We don't know what m is, we don't know what c is. To find m, you differentiate the function that is given. After you get a derivative, the derivative has variables. M cannot be a function as well. So there will always be a point that will help you get the constant m. So here we have a point -1, -1. Where there is x, you take -1. Where there is y, you take -1. And dy dx at that point is what is going to be called m. So you get half. After we get half, we take it in the equation. So now we have y is equal to half x plus c. What is unknown now is c. But the good thing is that we still have the very point. So you go back to the very point, where there is y, you take the y coordinate. Where there is x, we take the x coordinate and then look for c. So here we'll have -1 plus half is equal to c. So this means that our c is going to be -half. So now you come back and say, now I know the equation. It is y is equal to m is half x and c is -half. You can leave it here. But look, when we are marking online things, they are very strict with issues of copying. If the paper is exactly the same with the neighbor, we give a 0, or if they got 10, we divide by 2. So if you're doing such a question together and you want to submit for marking in the quiz, what the other one can leave the answer here. The other one will multiply by 2, and the answer should be 2y is equal to x minus 1. This 2 is a solution and it's very correct. So you change the ownership.
Now, sir, how would you, when submitting, maybe you are not in the same place, maybe different places, and then you have the same answer, will they be cautioned again?
It cannot be the same. You know, mathematics, mathematics, have you seen all these steps?
Yes.
You cannot write like this if you're not together. You also have your own methods and your own ways of getting the solution. Math is somehow similar. So your answer should be similar, but not exactly the same. Even if they're exactly the same by chance, it won't be the whole paper. Not where question 1, same things. Question 2, question 3, question 4. Do we have a question here? Or this is a done deal?
Done deal.
Okay. You can just sample another one. Let's do B. B is, no, let's do C. C, x plus y to the power 3 minus x power 3 minus y power 3 is equal to 0 at a point 1, -1. So we know that we are looking for this line, mx plus c. But the equation of m is the derivative of this function evaluated at a given point, 1, -1. So we're looking for dy dx. That's our first thing to do. Now to look for dy dx from this function, we differentiate using implicit differentiation. So we drop the power and we'll get x plus y. This will be power 2 now. Using chain rule, you go inside and differentiate x. It will give us 1. Differentiate y, you get 1. And then multiply the 1 by dy dx. Okay. That is chain rule. You differentiate the power and then differentiate the inside. Minus, differentiate x to the power 3, it will be -3x squared. Differentiate y power 3, it will be 3y squared. Another dy dx. This is 2 equal to 0. The derivative of 0 is 0 because 0 is a constant. Then you expand, so you get 3x plus y squared. Or since we did the solving of that thing, here we'll do it in another way. When I reach here, I substitute whether there is x, I take 1, whether there is y, I take -1. So we have 3, 1 minus 1 squared multiplied by 1 plus dy dx minus 3, where there is x, I take 1, where there is y, I take -1, and then dy dx is equal to 0. This here is 0 because we have 3 by 0 by this. So everything has become 0, minus 3 dy dx is equal to 0. So dy dx is equal to 3 over -3, which is -1. So what does this mean? This means that our m has been found. So you go back and say y is equal to -1 multiplied by x plus c. This is the same as y is equal to -x plus c. So we're now looking for c. So we go back to the point where there is y, we take -1. Where there is x, we take 1. And then we have the c added. So c is equal to 0. And so the equation y is equal to -x. This is the line that we're looking for. Have a good day.
So why can't we just finish up
before you
the rest and can watch the recorded one, eh?
What? No. We have actually finished because it's 1 hour. And the 1 hour is almost.
Oh.
We'll have.
The class has finished.
Yes.
Yeah?
But can you go back to the previous example?
We go back to the previous example. The previous example is example A. Okay.
Thank you.
You're welcome.
So that's only when joining some of us.
Yeah. We'll send you the recording.
Shimon and Joga.
Oh, yeah, you.
This is when you are waking up.